Good day to every one of the researchers and attendants of this very important event. My name is H Guerrero, and today I will present some of the results we obtained in our study about acid activation of bentonite clay for recycled automotive oil purification. First, I will give an outline of my presentation. At the beginning, I will discuss some of the aspects of the use and disposal of automotive lubricating oils. Then I will give you some of the objectives that we established for our work along with the methodology we used. I will also discuss some of the results that we obtained and will review some of the main conclusions we have derived from the work we performed. First of all, motor oils play a very important role in the operation and performance of a vehicle, being one of the products in greatest demand around the world. Once motor oil is used in a vehicle, it becomes contaminated, and used motor oil needs to be purified because it is also considered a dangerous waste, taking into account that 1 gallon of used motor oil could contaminate up to 1 million gallons of drinking water. Additionally, the increasing motor oil demand combined with the decreasing availability of crude oil requires that used motor oil be reused. For these reasons, the scientific community and governments have focused on developing efficient recovery processes for used motor oils. These processes, of course, should be applied at industrial scale, and therefore they have to be cost efficient. Used motor oil purification technologies include several stages, and one of these stages is finishing. During finishing, we remove some substances such as chlorine, nitrogen, sulfur, oxygen, peroxides, among others. And these substances are the ones that give color to the oil and increase its acidity degree, the total acid number. Finishing, which is contaminant removal, can be performed by adsorption. Adsorption is one of the most common processes that can be used for removing contaminants from different substances, including used motor oil. And the most common absorbents include natural clay, activated clay, silica, activated carbon, among others. Clay has a layered structure, as the one that you can see here in the slide, and this helps absorbing contaminants found in used motor oil. Among the clays, you will find that bentonite is the most widely used, and it is activated to improve its contaminant removal efficiency. These clays are also the most economical materials that you can have for the used motor oil regeneration. And when activation is performed, this increases the interlayer spacing that you have in the structure of the clay, and this helps improving also the contaminant removal efficiency. Therefore, for our study, we established as an objective to study the modification of bentonite clay through acid activation for purification of used motor oils. And at the first stage, we wanted to perform an activation using sulfuric acid, acetic acid, and the mixture of these two acids. We also, for the second stage, wanted to characterize the clays that were activated, and for that purpose, we will use the X-ray diffraction, infrared spectroscopy, and scanning electron microscopy. For the third stage, we wanted to analyze the treatment that we had performed on the used motor oils that we obtained by using the activated clays that we have prepared. As for the methodology, we used methodologies that were already published in the literature. And for that purpose, for the acid activation, we used the bentonite clay that was found in Ecuador and with a particle size of 75 microns. And we mixed these clays with acids, which were sulfuric acid, acetic acid, and a mixture of acids with concentrations of 20, 40, and 60%. Once we had the activated clays, we mixed these activated clays with used motor oil, and in this case, we used a concentration of 25% of activated clay and a contact time of 12 minutes. After this process was carried out, we characterized the treated motor oil. So here we have some of the results that we obtained. As you can observe here, we have the X-ray diffraction pattern for the natural clay here. And for the activated clays using acetic acid, sulfuric acid, and a mixture of these two acids, in every one of these cases using a 40% concentration. As you can observe, there is a decrease in peak intensity in all the activated clays, which demonstrates the changes in the mineral composition that we have in the materials that we are analyzing. The change is more visible here for the case of calcite. Here you will see for the natural clay a very high intensity peak. And for the activated clays, you have reduced peak intensities, as you can observe. Here you have the infrared spectrum for the natural clay in blue, and you have the spectra for the activated clays using sulfuric acid with 20, 40, and 60% concentrations. The clays activated with 40 and 60% of sulfuric acid show a decrease in intensity in these characteristic bands in this region that you can observe here. And this is due to the structural change because of the acid attack. There is also a change in the intensity in this band that you have here. And in the activated clays, you see that there is a decrease in this band, and this is related to the carbonates loss. And of course, this is due to the acid attack. Here you have the infrared spectrum for the natural clay again in blue, and this is compared to the spectra of the clays that were activated using the, in our case, acetic acid with concentrations of 20, 40, and 60%, as you can observe in our case. It is evident that the acid attack has not produced significant changes in this case, because the acid is not as strong as the sulfuric acid, but has other advantages in our case that are relatively important. And there is also a significant decrease in the intensity of this band found in the natural clay also. This is related to the carbonate depletion, as we mentioned before. In this slide, we find the spectrum of the natural clay compared with the spectra of the clays that were activated using the mixture of sulfuric and acetic acids, as you can see here. And well, as you can observe, the intensity of the characteristic bands of the structure of the bentonite clay decreases for every sample in this region, as you can observe. This reflects the structural change because of the acid attack. This behavior is similar to the one that we shown for the activated clays using sulfuric acid. And the only difference is that with this mixture of acids, the carbonate band, the one that you have here, has basically disappeared in the activated clays. Well, in these scanning electron microscopies, you can show also some images for the natural clay and for the activated clays using sulfuric acetic and a mixture of acids. This activation process changed the color of the clays, as you can observe here. The modified solid morphology is related to the exfoliation or the lamination of the mineral, as you can imagine. So once we obtained the activated clays, we started treating the used motor oil using these activated clays. And the processes can be evaluated, first of all, from the visual point of view. And as you can observe, the used motor oil was very dark here. But when you treated this used motor oil using the natural clay or the activated clays, there is a change in color. Just using the natural clay, color changed from 8 to 5. This is related to the removal of contaminants. But the most effective processes were the ones that we performed using the sulfuric acid activated clays and the mixture of sulfuric and acetic acids for the activation. In this case, color went from 8 to 2 in the ASTM scale. This, of course, was verified when we measured the transmittance in the treated used motor oils. In these cases, the transmittance was highest in this case and in this case, with the activated clays using sulfuric acid and the mixture of sulfuric and acetic acids with 40% concentration. From the purification efficiency, you can see that the activated clays using sulfuric acid and the mixture of sulfuric and acetic acids with 40% concentration were the most efficient to remove contaminants from the used motor oil, as you can observe here. Also, you can take into account this spectra in which we compared the untreated oil here in red, and also the oils that were treated with the activated clays in this case. The changes in the spectra verify that there is an efficient process regarding the removal of contaminants in these cases. For instance, in this region, when you observe that there is a remove of some substances that are related to the contaminants. So, as a conclusion, we can mention that the characterization of activated clays using, in our case, infrared spectroscopy, X-ray diffraction, and scanning electron microscopy showed the structural and morphological changes that occurred after the activation processes. This activation contributed to increase the absorption efficiency of the bentonite clay and to remove the contaminants of the used motor oil. The activation with the sulfuric acid showed the most noticeable effects on the morphology and structure of the natural clay, and this also resulted in the highest efficiency that was something like 3.5 times larger for the case of the clays that were activated using 40% sulfuric acid when compared with the efficiency that we obtained using only natural clay, which was approximately 20%. We didn't show these results, but we also determined the total acid number of the treated used motor oils, and this number decreased from 0.35 to 0.007 when we used the activated clays that were activated with sulfuric acid. In this case, the viscosity of the treated oil also increased from 85 to 111 centistokes almost. And this shows also the efficiency of the contaminant removal process using these activated clays. Well, having these very promising results, we are thinking about some future work, and for that purpose, we are thinking that we could use some additional combinations of acids and changes in the bentonite clay activation parameters to see if we can obtain higher efficiency. There is also an interesting possibility regarding the commercialization from the point of view of costs. There is also an improvement that we are looking for in the clarification efficiency, and for that purpose, we want to try to optimize the process variables during the treatment of the used motor oils. So, I hope that my presentation was interesting for all of you, and if you have any question, I will be very happy to answer